Hey, welcome to another video with Bogdan Majeski where we make algebra easy just for you. In this video, we're going to make connection between quadratics, equations, and graphs. So let's go. Just quick refreshment. Quadratic equations are in the form of ax squared plus bx plus c is equal to 0 with very important restrictions that the coefficient a cannot be equal to 0. So you have it, where's my magic pen? Right here. So this is very, very important. Every time you have the equation, you must have x to the power of 2 in order to be considered quadratic. So you already know that. So in this example that you're familiar with from the previous videos, you could solve it by factoring or any other method. We did solve it by factoring. So let's sort of refresh quick steps. We identify coefficients a, b, and c. You can take a common factor if you choose to, like factor 2. And at this stage, when you find factoring for form for this trinomial, with that existing factor 2, you can quickly proceed to answering the questions. The zero principle in algebra means that if you have one product of two factors rather, then either one could be 0, right? They don't have to be at the same time equal to 0 simultaneously, but one would be enough to make this entire equation equal to 0. That's why you have two possibilities, two answers. This factor 2 is never equal to 0. Obviously, it's not part of a solution. So at this point, you could divide both sides of the equation by 2 and then proceed to this form of the equation that you have here. Or if you didn't factor, let's say you didn't factor, you want to create that. You may also find that this factored form would lead to the same answer. For example, I would keep that 2x plus 5, and if I were to go and multiply the second set of brackets by 2, because you can, so you would get 2x minus 2. And the solution would give you the same reading, negative 5 over 2, or 1. Or you would say, what if I were to factor 2 from each set of brackets? So that would bring you 4 outside. And then solving this binomial, x plus 5 over 2 would give you negative 5 over 2. And x minus 1 equals 0 would give you the solution x is equal to 1. Or if you were to put back that factor 4 inside, so you would multiply by 4 to get 4x to get 10, and you still would receive the same answer. So how does it connect with the graph? So we are using Desmos Graphing, the free software that is available throughout the world for all of us. So use it. It's available, and by entering to Desmos, you can enter this trinomial as y is equal 4x squared plus 6x minus 10, or you can just simply enter the trinomial 4x squared plus 6x minus 10 without making it equal to 0. The moment you make it equal to 0, on your screen, instead of seeing the graph of the function, you're going to see two vertical lines that go through specific point on the x-axis. Those points are already known. They are negative 5 over 2 and 1. So we call those points, when we have a graph, 0 values of the function, right? So you have the one description. You can call them as x-intercepts. We can call them as roots of the equation, and obviously solution of the equation. So there's 4 different ways of describing the same thing. If you talk in geometry, then you're referring to x-intercept and 0 values. If you're talking about functions, when you're talking about equations, then you have those two names that are describing the same results, the same goal. So when you solve it, every time you solve equation, of quadratic nature, maybe linear, any equation that you can solve, please verify this graphically. That would sort of solidify your understanding, your learning, because quadratic equations are related with quadratic functions. If you already watched the video with quadratic functions, then you kind of see the connection. If not, you will learning about that just in the near future. Okay, so in this example, we have coefficient a negative this time. So quick review to the previous example. Positive a coefficient would result with this parabolic shape that is opening up. So that's sort of the general rule. Positive a, whether it's small or big, it always makes that parabolic shape open up. In this example number 2, we have a is negative 3. Therefore, you see the parabolic arch pointing down. But what we are interested about, if you solve it by completing the square, this is the lengthy method, but it leads to the solutions. We talked about it already. Just a quick refreshment. Your goal always is to take out the coefficient a from the entire equation so that you can work with the remaining pieces, which is x squared minus 7 over 3 minus 2 when you divide everything by negative 3. And then the procedure is that you divide the middle term, negative 7 over 3 in this case, by 2, and you insert 0. This is the 0 principle in algebra. At any given time, you can add 0, and you can define your 0 by creating a sum of opposites, like 5 plus negative 5, 2 plus negative 2, any fractions, 1 over 2, and negative 1 over 2, and so on. So that is the principle that you can apply when working with this strategy. So the reason that we do it, so we create perfect square trinomial, which was discussed in the past videos. So hopefully that makes sense now. If not, please review the other video. And then you convert this trinomial into perfect square binomial so that you can solve it by simplifying it and square rooting both sides of the equation. So if you were to simplify, you would cut the 3 and 3 from here, because that would be negative 3 times 121 divided by 36. Then square root it, you get 11 over 6. So you add 11 over 6 or you subtract 11 over 6 from 7 over 6. So this is the sort of quick review how we solve by completing the square. Now, graphically, this means that you have two roots. One is negative 2 over 3, and the other is 3. Please note that any graphic software that I am aware of, at least at this point, always converts decimals, fractions into decimals, so that you have to be aware of that. If you do solve by using your calculators, you're going to divide 4 over 6 to get 0.666, etc. So that you have to understand that this is not the anticipated answer because it's not exact. It is a good idea to use your calculator when you solve word problems. In mathematics, you want to show exact answers. So keep in mind, this is negative 2 over 3 in the end, not 0.666, etc. So stay away from those ideas. And again, the solutions that you get, that you see on the screen of your software, represents or correspond to roots of the equations, solutions, x-intercepts, or the zero value of the function. The next example that we solve by using quadratic formula, and we do that by knowing the quadratic formula, identifying coefficients a, b, and c, proper substitution, and it shows right here. You can use decimals to find yourself or to confirm your calculations by properly entering the entire equations the way you would do it on paper. So it is important for you that you develop skills with algebra when working with numbers, because later when you work with variables, you may find it very challenging and difficult, and you're going to say mathematics is terrible because it's hard, it's impossible. But if you go back to build your foundations, then you will be okay. You will not see it as that scary. So in the end, you get 1 over 2 and x is equal to -3 as 2 roots, 2 solutions. Now on the graph, you see exactly you have the 0 values for the function or x-intercepts. And this is the confirmation whether the answer that you have obtained by using this particular method does make sense. One more thing that you want to mention in this video, that you may have quadratic equations where sometimes there are no solutions at all. So graphically what it means that the graph of the parabola is positioned entirely below x-axis or entirely above x-axis. So that turning point, if you're familiar with the vertex, is positioned when the parabola opens down below x-axis. So whether x is positive or negative, it's not relevant, but the y coordinates is negative. And conversely, when parabola opens up, so the x coordinates could be positive, negative, right? Because you can have location and to the left or to the right, but the y coordinates of that vertex must be positive. So in this case, we have no x-intercepts. We have no 0 values. So if you were to solve this question by using any method, factoring would not work. When you use quadratic formula, please note that this shows right here on the screen undefined, because the square root from negative number does not exist. So the discriminant, we call it b squared minus 4ac. It's a discriminant of quadratic equation formula is negative, so no real solutions. Therefore, it shows on the graph that there are no x-intercepts. Also, you may have a possibility where your equation has 1 x-intercepts, which coincide with the vertex of the parabola, so that this particular example would show 1 solution. So now, at the end of this quadratic equation process that we covered for you, you are aware of 2 solutions, 1 solution, or no solutions at all. So second degree is equivalent to exponent 2, which sort of tells you how many possible roots you can have. 2, up to 2. Therefore, you can have 1 because 1 is less than 2, or you can have none because sometimes parabola is positioned on the graph with the vertex and opening so that there's no way you can get x-intercept. So hopefully that video serves you and you like the methods that we discuss here, and that sort of further your understanding about quadratics. Practice questions, it's a must. Please always continue learning with application. Apply your learning immediately into practice so that you know that you're doing things the right way. And thanks for watching. Share a video with your friends. We'll see you next time. Bye for now.